But like, yeah, and I guess this is just like more in depth or more in the application and how we use it and stuff like that. So, what are composites? So, in class, you probably learned that it's a combination of two or more different materials that are combined together. And this combination of materials, like you just call it like one material, or you just call it like composites. And it's pretty much the reason why we do this is because if you combine certain materials, you can get stronger, um, like a stronger single material out of it. So some common examples of this are reinforced concrete. So concrete does really well in compression, but it does very poorly like in tension. So that's why you add like steel rebar through concrete. That counts as a composite material since you have the steel and the concrete. You have plywood. So plywood's pretty much like the sheets of wood, but also the glue that like holds all the sheets of wood together. And then you also have fiber reinforced plastics, which is like carbon fiber, fiberglass, Kevlar, and so on, which I'll talk more about later. But yeah, and like this should be fairly like this shouldn't be new info to most of you, I think. So why do we use composites? So the most obvious reason for better like strength to weight slash like size ratios. So having this feature, it allows engineers have more complex designs, allow for bigger structures, and allow for like better functionalities depending on what you're making. So you can imagine like like we wouldn't have skyscrapers if we still had to build buildings with like cobblestone. Having steel and reinforced concrete that allows buildings to be like bigger, and then certain things with like for example boats. Now you can have a lot faster and faster and lighter boats because instead of making this boat's hull out of aluminum or steel or whatever, you can now make it out of fiberglass. And pretty much the use of composites is used like everywhere. And learning more about composites is definitely very useful. And like I would probably consider it like one of the big areas of like mechanical engineering that is relevant in almost every industry. So um, wait, and before I continue, does anyone have any questions on like the general sense of like composites or anything? No? Okay, cool. I'll keep going. So one type of composite, it's called fiber reinforced plastic or FRP. So pretty much uh, it's exactly what it sounds like. It's pretty much just plastic reinforced by fibers. And the fibers, it can be like fiberglass, Kevlar, carbon fiber, like aramid. Like there's a bunch of different fabrics you can use um, for FRPs. And then you usually encase those fabrics in a resin. So if you look at, let me turn on a pointer. So that's pretty much your fiber. And then you encase it in a matrix of usually like it's like resin, like hardened resin. And then after you kind of like let it harden, you get a composite material, which here is like a composite panel of something. And you see it looks very glossy. And it's glossy because it's encased in plastic, but you see like the carbon fiber textures, that's from the carbon fiber cloth. And that's usually like a soft material. Um, and so pretty much like the reason why you want the fibers is because the fibers have really strong tensile strength. If you take this fabric and you try to like pull it apart, it's really hard to like snap. However, it's very loose, like you can't really build anything out of a cloth. So what you do is that you encase it in like plastic, because like plastic is very moldable. It holds its shape. Uh, as long as you have a mold to the shape of like what you want to build your carbon fiber part 2, for example, you can kind of like lay up the fabric onto that mold and then make whatever shape you want as long as you encase it in this epoxy, which is kind of like it's it's just like a really it's like a type of glue sort of like you can imagine like clear glue, like you squirt it out of a bottle and like you let it sit there for a while, like it cures. It's sort of like that, except once it actually cures, it's like a legitimate plastic. And then once you have this combination of things, you get uh, like very great material properties that like you wouldn't get from any other materials. Uh, does anyone have any questions about this? Okay, cool. Um, so some material properties of FRPs. So this is sort of um, like relative. Like I'm not saying like FRPs are like stronger than like other materials. It's just like usually when you pick to use like FRPs, these are like the reasons why, or these are the best features that you want to use them the most out of. So some of the pros are that you have a high tensile strength, you have a high yield strength to weight ratio. So in other words, it's just very strong for its weight. It's usually non-permeable, which means that you can make like water pipes out of them, and like the water pipes won't leak. Like it doesn't have anything like seep through, and you could hold the vacuum within FRPs. And then if you add a core um, like um, to these FRP panels or these parts you're making, you can increase your moment of inertia, which makes your parts stiffer. I'm not sure like if you guys remember like the variable I that's used in a lot of equations, like your beam deflection equation, like your bend equations and whatnot. If you add a core in between two layers of composites, then you increase your moment of inertia because you're just making it have a bigger cross-sectional geometry. And like there's more to this. And like I suggest that like if you're maybe a bit confused, you can ask me questions later, or you could just Google like these underlined words. They're and like this is sort of just like a base point, and I'm sure that you guys can learn like way more than what I'm sort of like just showing you guys right now. And then some cons, usually some cons of FRPs is that you have a small plastic deformation zone. So usually with metals, if it's going to break, or you know, sometimes you'll see it like slowly bending and you'll see it like plastically deform, and then you know it's going to fail. With composites, like if it fails, it's going to fail instantly, and like you'll see no warning signs. So that's kind of bad, like depending on what type of thing you're making. Like if you're making like a panel of like a car or something, like it's usually fine. But if you're making like let's say like a bridge, it's probably not the best because if it fails, it's going to fail like suddenly. And unlike metal, you'll see like signs of wear or like deforming and things like that. And then after that, you have a low compressive strength. So um, with have I guess like I think you guys have learned about buckling. Um, not sure, but if you haven't learned about buckling, it's pretty much like imagine if you have like I don't know like a ruler and like you like push it in and you'll see like the ruler like bend. Um, that type of failure, it's called buckling, and pretty much uh, like FRPs, they tend to do poorly in situations of buckling because the fibers they're very slender, and the more slender something is, the worse, uh, the greater um, the greater it will fail in buckling. Or if you can imagine, like if you have a weave of like spaghetti noodles, like if you try to pull it, it'd probably be stronger than if you kind of like push it together. And then after that, you have low operating temperatures because at the end of the day, the temperature that you have your FRP parts in are limited to the melting point of the plastics you use to encase like the fabrics. And yeah, yeah, I probably rambled a lot, but there's like a lot more about um, this type of composites and things like that. Does anyone have any questions?
I think that was a pretty good explanation.
All right, cool. Okay, moving on. Some other factors like non-material related. I guess like the pros, yeah, like it has good material properties. I guess like it looks cool. This is the Koenigsegg. It's like one of the world's fastest cars. It's like made completely out of carbon fiber. Some cons of it is that it's usually pretty expensive. It's difficult to manufacture, or like the steps in manufacturing carbon fiber parts, they're very extensive and they're very unique to every sort of application. And then it also requires a lot of material testing. So depending on your manufacturing methods and how you make it, um, and like the different complex geometries that you can have, like usually companies that work with composite materials, they test it first, and then they are able to calculate, like perform their calculations based on their testing. Whereas, compared to like a block of steel, if you're making like a part from a block of steel, like if I get a block of steel, like if I buy it myself versus like if a company like in the US buys a block of steel, we can expect the same material properties in both of our blocks of steel. Um, However, with composites, it's not really like that. And that's why, um, a lot of people do testing themselves to make sure that they know the capabilities of what they're using. And that's kind of like leading to a reason for the last con, which is it's kind of difficult to predict how it will act. And again, it's like like a block of steel versus like something unique that you'd get that's probably like a very bit different, or varies largely in difference, like all around the world. So here's a very brief manufacturing overview. Like this should probably be covered in like a future like 101 or like document or something else, because it is very extensive. And from this, um, like don't expect to like be able to like make any parts or design any parts using composites. It's sort of just like an intro so that you guys have a base to build off of and like sort of like self-learn a lot of things to work yourself into designing these parts and trying to like make these parts by hand by yourself. But here's a brief overview on how we make our carbon fiber parts. So we machine some molds. We have surface finishing on the molds, and then we do the layup. So the layup is pretty much just like laying up the carbon fiber fabric on the molds, and the molds are the shape of the part of whatever we're making. After that, you want to, if you have, usually you want to do infusion because you have the fabric and then you want to run the epoxy plastic through the entire part. However, we use pre-impregnated carbon fiber, uh, which is pretty much just like the glue's already in the fabric, but it's just frozen. And then to cure it, you just need to heat it up. And then after the resin is cured, you can pull the part out of the mold and you'll have your carbon fiber part. And yeah, and again, this is just like a very brief overview. It's fine if like you don't understand it. It'll probably be covered like later on. So here's some video links I found that were like kind of useful. So like there's like just some few things with like regular carbon fiber infusion, and then it kind of like works all the way down, to like some random things like mass manufacturing with like carbon fiber parts. I think it was like BMW making like roofs, like roof panels out of carbon fiber, and like how they do it. And I think like watching all these videos, and you will see like the uniqueness in how everybody does it. Um, and you'll sort of realize that like uh, composites is it's like a lot more complicated than just making regular parts. And then lastly, here's some other resources. So here's like a few websites that I've like looked through before. I just found this one today. Uh, it's actually really good. It's I think like even like a child could probably like read through this and understand uh, what's going on. But uh, so it's called Composites Lab, and it's pretty much just like a bunch of info on composite material, and you could see like, oh, like how does it like stack up against steel, and like what applications does it have? Like, oh, I wonder what carbon fiber is used in sports and recreation, and then I'll tell you all about it. And yeah, so yeah, that's pretty much it for the one-on-one. Does anyone have any questions?